how many are there? Anybody has logged in? Shall we wait until somebody joins?
Hello, welcome to this live chat. Here we have Professor M. Chalapati Rao, and then we have Vinod Hegde, and myself, Ashwath Narayan Singh, will be coordinating between their questions. Okay. Anybody there from the other side? Or you can type in. You can type in. Yes. If you have any questions, you can type in. We'll just see if you have any doubts. We can clear. ನೋಡಿ ವಿನೋದ್ ಹೆಗ್ಡೆ ಹೆಗ್ಡೆ ಗೊತ್ತು ನನಗೆ ವಿನೋದ್ ಬರ್ತಾರೆ. I think nobody on the other side, only one person. We'll see. You log in and then ask any questions.
Let's just say something.
No, not required, because on the other side somebody should be there.
Yeah, correct.
Hello. Anybody on the other side? You can just type in, telling that we are present there. So we'll know that we are not just talking to the TV. Okay. Yes, sir. Any question?
KST na. Every year we take projects. This year, 5,000 project proposals have come. And they will distribute it for 10 people. So 10 to 20 people. So I'm one of the people who has volunteered some 15-20 years back. So right now, today, now college-wise, they will give the things. And college-wise, and it's a big matrix. College, branch.
Okay. So that in the
Computer science, some people are there. Mechanical, some of us are there.
Okay.
Then chemical, then all this, biotechnology, all the people are there.
ಅಲ್ಲ ಯಾರಿಲ್ಲ ಆ ಕಡೆ. I have just told them, just let them key in so that we will know that people are present on the other side.
4 people ಇದ್ದಾರೆ. ಬಟ್ ಅವ್ರ ಹೆಸರೇ ಬರೆಯಲ್ಲ.
Okay. Okay. If you have any doubts, you can just type in.
Should let's repeat again.
Yeah, new method. You just have a.
Somebody has come.
I think there are some.
This will be recorded, no? It will be available afterwards, offline. Somebody can see.
Okay.
Hello. I thought I'll give you an introduction on the context of the course. Anyway, content you will be going through for a long time. So if you see development of any electronic product, obviously two distinct fields are there. One is users, how the user is able to use it, and how it is used in the given environment, and these things. These are best done by a field called industrial design. So we all belong to the industrial design studio in Indian Institute of Science. Followed, no? Industrial design talks about how everything looks, what it's supposed to look like. Now, another equally important area is the functional aspect of it, saying how well the electronics work and what is the thermal aspects of it, and what is the EMI aspects of it, and what are the current voltage and all that. Traditional electrical and electronics concentrated very much on the functionality of those things. Of the late, maybe around 30 years, they have found out things like heating, and then the radiation pickup, and then the reliability. That is, if you have a connector, it will have a usually a sliding contact or a butt contact. The reliability of it, all that has come into aspect, which has again become specialist. Now, somebody has to integrate all the aspects and make a useful thing like a product. Like if you have, for example, this, I got the correct thing. We all know what it is, no? It's a power bank. Power bank could just mean a few batteries and all that. Now suddenly you see no two power banks are the same, and you have a preference. A good power bank costs 1500 rupees. A bad power bank costs probably 500 rupees. And the difference is all in how well these things are executed, how these are put together, how much does it weigh, how does it feel, and should these connections be on top or should be on the side. Have you seen the older power banks, the input was on the side. The new power banks are all on one side, not on one here and one here. Now, why did this come about? This is the context of the course. Traditionally, this is all done by a specialist who was a product packaging person. But then obviously, if you want to get into product packaging as is practiced by the big ticket companies, it's very, very expensive. It's a huge set of people who work, who conduct research and each and every aspect of it. So a very simple thing like if you take a USB is not a physical idea. It is a interface. You understand? No, it's only an electrical interface. Nothing talks about how it should be or anything like that. So any serial interface, by definition, no, has only two wires and occasionally a third wire. Actually, two wires is sufficient for any serial communication. Got it, no? But then the moment I say USB, you all remember what is there on the computer. That's called the type A. And then what is usually in your mobile phone. So now there itself, now there are nearly 8 variants of the that physical manifestation or occurrence of the so-called USB interface. Now, already I'm sounding too complicated and out of context. But the thing is, as a student who or a practitioner, as you are there now, you need not worry too much about how to put this thing together. We again end up with chicken or the egg, saying, do we have the circuit and then we make a box around it, or you decide an enclosure and you put electronics in it. So both are required parallelly. Somebody needs to worry about how the phone is used, how do you use it, and all of that thing, and somebody has to decide on how to make the circuits. So we all know this is a good company called iOS. And you'll be surprised to see that 7 or 8 antennas are stuck inside. 7. This has what you call wireless charging also now. And I do not know how many cameras are there, why it is or anything. Now, if you are one of the designers who has to do it, 2 levels you need the thing. One is inside how it's going to look, outside how it's going to look. All of you in your college or in your, if you're a person who's a startup or on your own as a design agency or at home or any other way, generally have, basically, you have a simple laptop. And in laptop now, various types of tools are available directly. You can download all sorts of tools. And only one small gap is there. If you want to make a circuit, lot of circuit maker tools are there. If you want to make a printed wiring board tools are there. And if you want an enclosure for it, 3D tools are there. Now all of them you can very easily integrate at home. Got it? No, you need not go to any specialist. You look around, look at things, and then make using an A4 plotter. You can take plots of it, and most plotters these days the accuracy is committed accuracy is 0.1. The real accuracy is 0.05. That is 50 microns accuracy. It is able to print for you. You can crease things everywhere, do everything, and make neat usable models without have to go to a model maker, or now the catchword is 3D printing. You need not do 3D printing. You can just make this out of available things. Now let us say you open the box, how do you arrange various circuits and all that? No, that is where I was telling you. If you open the that any cell phone or any of your things, you will find several of the printed wiring boards. And those of you who are in electronics, so you all heard of now ubiquitous Arduino. Then we heard of Raspberry Pi. We also heard of Zigbee. And then we also have what do you call 1, 2, 3, 4 versions of Bluetooth. And all of them have small antennas. And magic is that antenna, those details are all easily available on the internet. You can go somewhere and then you can just capture the file where all the dimensions are there, and nearly usable layouts and all you can make using things which are available in your this thing. That is how the context of the course has started. Now, getting back, our Mr. Singh was trained by the Swiss people and also at IIT Bombay in the IDC center. I myself was an ex-defense person. 10 years I worked in defense production and came over, and I also deal with this thermal and all that. So I'm happy to share this information with you, and I'm very sure within this around 2 months, 8 weeks, you will get just at least some idea of how to proceed with it. And absolutely, now that internet is available, uh, all the resources are available for you, and very easily you will be able to make a start for your projects. Now, instead of getting stuck about it, no saying, do I only make a circuit and leave it, or do I only depend on a concept model? I expect as a engineer and as you, with your eagerness, you yourself will be able to make everything. Not impossible for you to make anything these days. Got my point? Very, very easy for you. You just want to make a remote control, which I do not know what it does. One thing is, it silences people who talk like me. If you do like that, no, cut. No, you can't stop me. Now the thing is, anything around, for example, lights in your house, they are very, very simple things. Several things we do not know how or what it is. The future is there for you people to try and do it. So you can always try a circuit on a, for the first time user, you do it on a wish board. I think you have seen those things, small things you put and all that. And if you know very well it works, then putting it in a circuit is very easy and simulation is easy. All that you can just do directly on your laptop with the various tools available. And if you're lucky and if you're in a college or if you're in an institution, higher, more powerful tools are available to do full mixed mode simulation for your circuits. So you can be sure right now a circuit is almost a generic thing which can be tried. What we yet don't have is the product as such. That is how so many things are existing peacefully. Not long ago, before this what do you call this sort of brick phones were launched, lot of thing was spent on the shape of the phone, shape of the key, shape of everything. Suddenly, that's not required anymore. You notice, no? Suddenly, that's not at all required anymore. All that you require is a flat place and how to arrange the icons, and you are done with it. Now, just like that has progressed outside, inside also tremendous amount of progress has been there in the electronics also. You can simulate anything, and finally you can make a very convincing prototype which you can present it to not any financier, not any what you call not in Shark Tank, but your other group members can easily be convinced by it. I hope you agree with me. So usually that question came saying, do I now buy a new phone costing much more because it has a 6000 milliampere battery? My phone only has a 3000 milliampere battery. You'll notice that the game is not about just the milliampere hours. It is about how well energy is managed. So I decided to do the obvious saying, this phone itself is a too much of money for me. It is presented, that's why I got it. And I went and bought this. This costs only 900 rupees. If I want the upgraded phone, this costs 1 lakh rupees. By just adding 900, I have an upgraded battery in this. The 3000 suddenly has become 10,000 milliampere hours. So whenever I want, I can do it. And both of these can easily be made at home in your normal inkjet or laser printer. In college, generally, you'll have laser printers. Make a 1:1 model, make a cardboard model, and print any graphics you want nicely. You can make something which looks like a camera here. You can print
layout of all the components.
Layout
of the
location,
components.
yes.
Graphics.
And as I say, camera is only one part which you are seeing here. But underneath, obviously, no, there are three printed circuit boards underneath. Similarly, there is again one more camera and three sensors are there on top. All these have, occupy real estate on the printed circuit board. And I said at the back, no, you have antennas and you have what do you call thermal dissipators, heat dissipators, and all that. No, this full layout very conveniently you can make. And if I open this down, no, I can see everything. I need not even waste one bit of plastic or sheet metal or anything. I just can make it on layers of sheets. I can carefully remove the layer of sheet, and then underneath I can see that. So this full very complicated things like this can easily be made directly if you think a little about it and after attending our class. And to make it little more presentable, Singh has gone and worked in our what they call workshop. He has shown things like how complicated it is to bend a simple sheet. That simple sheet bending is very, very complicated because you do not know the physical parameters, especially relating to what is called the bending elements and what is the behavior of the material. But all that now, all the information is available on the internet. You take it from the necessary, what you call machinery book, and then you make things directly, make a flat sheet, stick it on the piece of metal, you continue all the operations and bend, and then nicely we have the whole almost usable box. And in fact, in one of the things we have mounted all the electronics and it's working. Only then we decided to make it in sheet metal, and that was already presented to you. So I'll stop. You having heard this, now tell me what is it, any information you want from here. Vinod, luckily, he's one of our master students, so he has volunteered to be here, and Singh has been with me for a very long time, maybe 30 years. 35 years. And we are there in, this was started with Swiss collaboration in the Indian Institute of Science. Now fully it is self-funded, and we are doing. And a lot of students have gone through courses here now, have benefited by it, and have referred back to us saying, this is a very unique course, kindly do. That is how we have given the whole thing. So I'll stop here. You can input.
Yeah, any questions you can just type it out so that we will know what you require, and then we could answer.
Last month there was one question of why to use a graph sheet instead of a white page. So you already explained in the video.
Okay.
But we can refer.
What does it say?
So I have a question about happening in the video. So this is why we use a graph sheet instead of a plain white page.
Okay. So, you answer.
Explained in your.
It is explained. Actually, graph sheets are more useful rather than white sheets. You take again. You have to make dimension wise. You have to use tools like scale or what or something. Here it's not required. Directly graph sheets are there. It's 1 mm and inches also there. So which is convenient for you. You can take them.
So,
and the diagonal, the square what we maintain is automatically maintained in a graph sheet. You have seen that, no? The square which you try to make with this thing, even if you are very good at marking, you end up with a very peculiar parallelogram, very rarely a perfect rectangle, and all your dimensions will be wrong. And another thing is calculation of area is very easy in a graph sheet. You just go on doing it. That's how traditionally all model making started as a graph sheet. And if you are one of the what do you call people who enjoy craft work, if you go to any of these art things, a big green colored sheet is available which has all the markings, and you can easily do anything you want in it. You don't even need to measure anything. You can measure outside and neatly cut, and everything seems to be fitting in place. Is it sufficient, sir? That is the reason why he uses that, and I have learnt it from him.
Actually, overall size graph sheet, if you have the product size itself, then you can place small components inside that and play with that layout itself.
Software is for prototyping.
Anything else? Somebody asked which software can we use prototyping designs. Traditionally, there are free, what you call, free per use softwares. You can go and try yourself. You understand? No, I cannot endorse any one particular thing. Generally, in Karnataka, both SolidWorks as well as Solid Edge,
Yes.
and also ProE, and then AutoCAD Inventor, and any of these things are available to the students. Student versions are licensed, and if you're a person in the college, you can do it. If you're doing it on your own, you can go to the internet, download things like Sketchup, which are available offline, and they're able to do it. Only thing is, don't use things like Word, MS Word, or what do you call PowerPoint and all that.
Photo editor.
There, the dimensions are not valid anymore. Some numbers are shown, and what is printed will be separate because it prints to fit the aspect ratio they have. Genuine other things, there is no problem. On the premises here, we have access to everything, including most of Dassault thing, most of SolidWorks, most of what you call huh? Yeah, all of these ANSYS and all that. Now we have access to it because they have given a general purpose license, and the institute maintains the license for all our students. But I have no access to it. I am no longer a student. I have to take permission from a student. So you make it for me and show it to me. You understand, no? I cannot now say kindly use this like this. So I suggest you ask your friends whoever is using it. No, people around here generally use SolidWorks. Huh?
SolidWorks.
And open source free CAD.
Okay.
Open source.
Any open source CAD now, because in this case we just need lines which are printable to the exact scale, and you need what is called overlay layers, one layer upon the other, and eventually if you want you need to make 3D things. Only problem for us is you are flooded with software which is used by construction people. You understand, no? All the beautiful renderings and all what you see in the newspaper, they're just made in old, I do not know, which is the old software they're making.
Maya.
That big buildings they show, no?
So I think
3ds Max.
3ds Max, correct.
Okay, 3ds Max and all are used for it. Now that is not 3ds Max itself is not be useful for you. But any version of the old clone of AutoCAD means all the things, everything will be identical to AutoCAD, but it will not have the full capabilities, and accuracy will be okay-ish. That's all I can tell. But it will not be a full mesh generator. Full mesh generator, if you take a solid, make a solid, it can cover it with mesh. Any 3 points will be coplanar. So this plan, things can be here and solids can be built about it. But that is beyond the scope of trying to make a simple prototype here. So my suggestion is use any freely downloadable, open sourceware from the internet, and which is working for you. And of course bug free and free of all sorts of virus on them. Generally, they are no problem. So you can go to most of these things and download it. What do you say, sir?
Yes.
Which is your recommendation?
So FreeCAD, OpenSCAD, so open
FreeCAD, does it work well?
Yes.
What all facilities does it have?
So you can code it and simulate, and also form of an other way of simulator also,
Yeah.
external simulator.
So you heard a student, no? Our MS student is telling you this FreeCAD is one of the useful programs. And
to even simulate basic simulation and understand what
yes, basic simulation regarding thermal or
not thermal, so just an finite element.
As it says, finite element also it can be done.
The external flexibility to support
basic dimension. The advanced programs generally materials can be included about it. Property of materials. One of the simplest property we know about is weight and surface texture. The complicated property is how it flows under what they call under pressure. And the very complicated is rate failure. We want to do fracture analysis and all, unless you have what do you call failure rate analysis, you cannot do anything with it. So they have all the advanced programs. And next thing what I wanted to do is, if you initialize with some basic 3D, that files can be used for 3D printing. Whatever you can see on the screen can also be sent to a 3D printing thing. If you send it to them, they will print it and give you. But there comes the great bug. What is shown on the screen, what is printed, and model units versus physical units, there is a little problem. So first time you will be surprised. Some of them look quite okay, but then you may notice that two parts, they may not fit automatically because the model units and the physical printable units have changed a little. But if you use your printer which is on hand with you, you can easily check. You can see if you make a 100 mm by 100 mm square, after printing you can check it will be 100 mm 100 mm square. And to answer another person, in fact, if you push a millimeter graph through it, it will print exactly, because that millimeter graph itself is printed on what is called a calendar press. A calendar press will be moving continuously, and they have errors up to 1 mm. While your printing machine is capable of printing 0.1 without any problem. You understand? No, printed graph sheets are probably more error than your local printer which you have on the table. Because they are printed on 22 inches width and it comes continuously, unbelievable speed it comes. So try everything, and then my student has given me FreeCAD as a thing, and I'm sure it will be very much possible. And you can in fact go to the search for it, and there are several softwares where it cannot save. Free trial is allowed for you, so you can do it, and then
some 20-25 saves.
20-25 saves. During that time you can print also. So if you make up your mind, you should be able to print things. Yes, sir. Anything else?
No.
Okay. Correct up on ahead, sir.
Yes.
So what do you say, Hede?
Yes.
Okay, we'll wait for 2 minutes. We'll see if anybody wants to.
Doubts.
Yeah, has to be cleared. We'll clear that one.
You can always type a question, and my project assistant, he has gone through this already. He has been going through this last 3 years. This is the 4th year.
2 years.
2 years.
2 years.
So 2+ years he has been going through it, and he has been following our logic. So he knows the actual problems. Same thing as your college. Well, you get as much information as possible from the lecture, and also slightly improved in the laboratory. Maximum amount of help you get is from your peers. Peers will explain to you what it is, and if I randomly say for matrix multiplication, how many nested loops are required? I have by hearted the answer without actually coding. I know it should be minimum 3 nested loops.
No, if it is a two-dimensional
Different.
too.
It's a two-dimensional to say as answered. We used to buy hard these things, no choice, way back in '67. But right now, your friend like this, he'll be able to tell you why is it, why A, I, J when you do, how that A, I is calculated, then J next is calculated, and this is nested in the other one. So he'll be able to very quickly, suddenly things will fall in place. And a very simple thing like if you're electrical people, how does an induction motor work? Understand, no? How does a rotating magnetic field work? How does an induction motor get its the other? How does it see the complementary pole inside the rotor? And why the rotor slots are not straight and they're all like this? These things by talking with your friends, in different departments, you will make it. You know the answers for all of it. Oh, why do you mean no? He will know. He knows. He doesn't want to commit.
Okay. Okay. No questions? Okay, then we will see you people in the next live session sometimes. Okay, bye.
So best of luck.
Yeah.
Please come, sir.
NPTEL folks are not here. Wanted to check that multimedia room, the TV. Oh, now the recording studio has moved here.
Yeah,
it
this
is
is
not
like,
there.
No, recording studio is there. This is live sessions we were having.
Oh.
See, I'm talking with my students who are somewhere else in the country.
Okay.
Yes.
So we three were part of the course. So the mechanical things he will do. He will do the what do you call